Are you paying attention at all to 3 Atlas? Are you watching the comet? Yeah. Whatever it is. Yeah. Yeah. I mean, one thing I can say is like, look, if I was aware of any evidence of aliens, you have my word. I will come on your show and I will reveal it on the show. Okay. Yeah. Abby Lowe was on the podcast a couple days ago talking about it. Yeah. Could be onions. I don't know. But apparently today they're saying that it's changed course. Did you see that, Jamie? It's fascinating. It's fascinating also because it's made almost entirely of nickel, whatever it is. And the only way that exists, here is, industrial alloys apparently. Zavo, a few hours ago, the first hint of non-gravitational acceleration, that something other than gravity is affecting its acceleration, meaning something is affecting its trajectory beyond gravity, was indicated. Interesting. So it's mostly nickel, very little iron. That's a real problem if it hits. Yes. No, it would like obliterate a continent type of thing. Maybe worse. Probably kill most of human life. NASA officials reveal they have decoded transmissions from 3 Atlas. What it says might change everything. 3 Atlas, the interstellar object once dismissed as dust and data, is no longer behaving like one. Its rotation has stabilized. Its trajectory is correcting against gravity itself. The telemetry isn't noise anymore. It's rhythmic, structured, deliberate. Astronomers are arguing over equations that read more like coordination than motion. If this isn't artificial, then physics is lying. And if it is, then the story of 3I Atlas has just entered a chapter we were never meant to witness. A flag in the system lock. The alert didn't begin with a telescope. It began with a timestamp. At 2:43 Universal Time, a faint object slipped through the ALAS survey's nightly feed from Hawaii. In the automated display, it appeared as a modest flag, a TLS 2025 or 2. The line scrolled past hundreds of others. Pixels, coordinates, velocities, nothing special. But the program halted. The motion didn't fit any known orbital path. The velocity was too high, the vector too steep, and the residual error too clean to dismiss. Within minutes, the system labeled it unbound. That single word moved it from routine detection to anomaly, an object crossing our sky but not belonging to our star. Atlas wasn't built to find wanderers from other suns. Its task is defense, mapping the near-Earth environment, tracing the faint threats that might drift too close. Every night it scans the heavens in twin exposures, linking points of light by motion and probability. Thousands of candidates vanish into noise. Only a handful become names, but this one persisted frame after frame. The trajectory refused to settle into a solar-bound curve. The math said the sun could never reclaim it. By the time dawn reached the summit at Mount Aloha, the data had already spread. Independent telescopes confirmed the faint trail, dim, blurred, but steady. The coordinates aligned perfectly. It wasn't debris. It wasn't a satellite. It was something passing through at nearly 30 kilometers per second, a speed too high for anything born here. The Minor Planet Center distributed the internal bulletin before noon. No headlines, no images, just a quiet notice that our system had been entered by a visitor from beyond. The official name would hold, but so would the unease behind it. If this one was found by accident, how many others have already crossed our skies, unrecorded, unrecognized, and gone before anyone thought to look up? Nobody looked up that night. The discovery reached the Minor Planet Center before anyone outside the network even knew it existed. A quiet electronic circular, no photograph, no press headline, just coordinates, brightness, and the provisional tag 3 Atlas. While the notice moved across servers in Cambridge and Tokyo, the world turned as if nothing new had entered it. No alarms, no broadcasts. Even the astronomers who read the bulletin did so between calibration runs, half aware that a third interstellar object had just been logged into human history. Interstellar detections don't arrive with spectacle. They arrive as numbers, ephemerides typed into command line. In the first 12 hours after the flag, the only audience was the network itself. Automated telescopes adjusting exposure tables, observatories queuing up requests for tracking time. 3I was already faint, its magnitude slipping toward 19. Any delay meant losing it to the noise floor of the sky. The next observing window was narrow, mere days before the object would fall too close to the sun's glare for most optics to follow. That night, the few telescopes that caught it did so through exhaustion. Operators stitched together short exposures between other tasks, guiding systems built for near-Earth asteroids toward something moving faster than any they had measured. The results were meager but real, a thread of light creeping against the starfield at 30 kilometers per second. Every frame confirmed what the algorithm had whispered. The object was unbound, inbound, and leaving almost as soon as it was seen. Beyond those control rooms, nothing changed. City lights washed the same horizons. Airliners traced their usual lines and no one looked up. The third known messenger from another star was crossing through Earth's neighborhood, and only a handful of people knew to point a telescope at the right coordinates. By the time the first internal summary circulated, it was already late evening in Hawaii and early morning in Europe. In inboxes around the world, a new subject line appeared: 3I Atlas preliminary parameters confirm. No photograph attached. No urgency suggested. Just a small note that our skies had been crossed again. Light collected in panic. The confirmation turned into a race. Once the designation went public, the global network of telescopes began to wake up. Robotic observatories in the Canary Islands, Chile, South Africa, and Japan, all competing against the clock. Every hour that passed meant 3 Atlas would move deeper into the sun's glare, where even the best optics would lose it. The urgency wasn't emotional. It was orbital mechanics. The object was moving fast enough that its position changed by thousands of kilometers between consecutive nights. Any delay, any cloud, and it would vanish from reach. Photons became currency. Each observatory collected what they could: a few seconds of exposure before dawn, a faint streak trailing across the sensor. The images looked almost identical, thin, featureless, the color of dust. But to those passing the data, every pixel mattered. When stacked together, the signal rose just enough to reveal structure in the noise, a slightly asymmetric brightness, pulsing in rhythm with rotation. It wasn't dramatic. It was measurable, and measurement was everything. The photometry teams worked through the night, correcting for motion blur and atmospheric scatter. Software attempted to model the spin period, adjusting for phase angle, searching for consistency. A pattern emerged, not perfect but persistent, suggesting that 3I wasn't tumbling freely like a broken rock. Its brightness fluctuated as if its shape, or perhaps its surface, carried geometry. That detail alone would redefine the observation strategy. Even with the best instruments, the data stream thinned quickly. The object's apparent magnitude slipped beyond 19, then 20. Smaller telescopes dropped out first. Only the largest mirrors, Hubble, Gemini North, and a few adaptive optics arrays, remained capable of following it. Researchers petitioned for emergency scheduling, squeezing 3I into windows meant for other science programs. For most, the reward was a blur that looked no different from sensor noise. But in astronomy, persistence is revelation. By the end of the third observing night, the sky survey logs filled with overlapping coordinates and exposure timestamps. What little light 3I gave up was already cataloged, shared, and archived. The rest would depend on the model. For now, all they could do was gather and hope that the next line of data arrived before the universe took its visitor back.